thousands of different kinds of reactions are happening all around us, right? Some certain sort of reactions you want to highlight, or I'd like to highlight, are combustion, which is burning essentially, anything reacting in oxygen to give off a lot of heat. And here's another one, rusting. So these are kind of reactions that take place with many different things. So every time let's say I say, oh, the gas is combusting, or the oil is combusting, or that car is combusting, what's coming to your mind? The idea that it's burning, giving off a lot of heat, right? And if I say the car is rusting, or the phone is rusting, or like that steel is rusting, or that rock is rusting, well, it's a metallic rock, right? So it's generally talking about metals, and it's undergoing a slow process, not too fancy like combustion, and it's undergoing a slow process where it's just not as shiny anymore, and it's starting to look brownish, reddish brownish, right? So you have a general idea. So these two reactions are a category of reactions, meaning that different things undergo combustion, and combine them, all different kinds, you can start generalizing them because so many of them you can start undergo combustion, you can start calling them a category and a general idea. So it's a group of reactions taking place, right? Similarly with rusting, it's not just iron, other things can rust as well. Copper, a very famous example is the Statue of Liberty. It's oxidized. You don't really call it rusting as well. It's not the official term. But technically what's happened to the Statue of Liberty, it's made of copper. Copper should be pink. But what's happened over time is the surface on the Statue of Liberty, the surface is all eroded, so to speak. The thing with copper is when it erodes, it doesn't look too bad. It looks like a nice green patina all over the Statue of Liberty, right? If it was iron, that statue would have been gone a century ago, right? So these are just categories of reactions, and redox is a category of reaction, right? A redox reaction is simply when oxidation and reduction takes place in a chemical reaction. It's understood as a redox reaction, right? So that doesn't really make too much sense. We have to now start talking about what oxidation really means and reduction. Another disclaimer, this chapter is full of disclaimers. Oxidation doesn't mean what it sounds like. It has very little to do with oxygen, and reduction, same, I don't know what is coming to mind. It has nothing to do with what it sounds like. Let's move on. So the highlight for redox is that it's all about electron transfer. So when a chemical reaction takes place, for example, magnesium over here and oxygen over here, you can understand that they're going a chemical reaction in this process, and they're exchanging electrons where magnesium loses 2 electrons to form the magnesium ion over here. This over here is an ionic compound, and oxygen gains 2 electrons. Each atom will gain 2 electrons to form O2 minus, and it's ionically bonded, right? So there's an exchange, or like a transfer of electrons taking place. Not really an exchange. It's an ionic compound. Here's what's visually happening to magnesium. Magnesium has 2 electrons, which it passes it off to oxygen, where oxygen ends up gaining 2 electrons, and magnesium starts losing 2 electrons, and they form an ionic bond because of the opposite charges they attract. Hence, there's a bond in the middle, and it's an ionic product where magnesium ended up losing 2 electrons, oxygen gained 2 electrons, right? So this is a visual way of understanding the same thing. We can actually see electrons going to oxygen. You can see over here, the dots are magnesium original electrons, and there are 2 of them now with oxygen. So it's gained those 2 electrons from magnesium, whereas magnesium has lost its 2 electrons. To represent the same thing in an equation, this is how we do it. You have 2 magnesium. Why do I say 2 and not just magnesium? Originally, the equation was 2 Mg reacting with O2, right? The 2 magnesium ends up losing electrons. This is how we write it. To lose electrons, electrons will be shown on the right hand side. Think of it this way: magnesium is broken into a magnesium ion and a few electrons. Left side is what was before, right side is what's after. Do not get confused with the plus sign. The plus sign doesn't really mean they're joining together. It's not math, right? This isn't math. The plus is kind of acting like a comma. It's separating these two quantities visually. It's a punctuation, so to speak. So the plus means magnesium and 4 electrons. If this wasn't here, they could have just as well put a comma, but it's, the status quo is to put a plus sign. This plus does not mean it's joining together, even over here. This arrow means whatever's on the left-hand side is reacting with each other to produce whatever's on the right-hand side. This is how you should start seeing a chemical equation. The plus is just a comma separating things, right? With that said, so you can say magnesium has been broken into 2 different things: an ion and lost a few electrons. Each magnesium lost 2, so 2 magnesium lost 4 electrons. Same with oxygen. Before, this is what you have, and later it ended up combining, because you have more products on the left hand side and less products on the right hand side. So they join together. Again, the plus doesn't really mean anything. You can see it as like an addition thing, but that would technically be wrong. But as long as you're not tested on it, you can think whatever you want. That's one way of looking at it. Let's move on. Yeah, before we move on, sorry. These are half equations. We'll deal with half equations a little bit more, but I'll restrict myself. We've already talked a lot in class about it, but I think for now, for video purposes, I'll make a separate set of videos how to talk about half equations, how to deal with them. It's better if I isolate things rather than put everything into one video. So this is going to be isolated. But make sure you have a good understanding of what exactly is going on here, right? And we'll move on now. Now, what exactly is oxidation? It's nothing more than a loss of electrons, which we saw. It's all about transfer of electrons, redox. So oxidation is considered as loss of electrons. Reduction is considered as gain of electrons, right? So when a chemical reaction takes place where both oxidation and reduction are taking place, it's called a redox reaction. Redox is reduction and oxidation taking place at the same time. It's literally in the name, right? Now, this doesn't really make too much sense, right? Like, oxidation is loss of electrons? Okay, all right, like, I'll bite, right? What's next? This is essentially it. That's it, right? But a good way to remember this is by the mnemonic oil rig. Oxidation is loss of what? Electrons. Reduction is gain of what? Electrons. Oil rig, right? That's how we'll remember it. Now, this moment on and going towards anything practical, it's a very mechanical process, very little understanding. Just have a big picture as to, just start thinking to yourself, why is this really so important? Or why are we talking about this? And a lot of things, once we start discussing it, will start falling into place very easily. We have the same equation we had last time where we saw magnesium losing electrons. If you don't remember, look at the equation at the back and especially the diagram. Now, once we've identified that magnesium is losing electrons, right? I'll just write a 2+ charge. It's not really written here. So from 0, it's going to 2+. Why does it have a 0 charge? Because the number of protons in magnesium currently and the number of electrons are equal, so it has a 0 charge. So it's going from 0, a charge of 0, to 2+. So technically it's losing electrons to gain that 2+ charge. So this is considered as oxidation because it's lost. Oxidation is lost electrons. I think if ever I've written something that didn't read too well, this is probably a fine example. I just don't understand what I just wrote down. I mean, I'm trying to say oxidation, right? On the other side, you can say what happened to oxygen. How do I make this neatly over here? Now, oxygen over here has a 2 minus charge because it's gained electron, if you remember from the diagram. So this over here is reduction, right? Now you say oxygen has been reduced and magnesium is oxidized. This is oxidation and this is reduction. Is this a redox reaction? What do you think? Yes, it is. Oxidation and reduction are taking place at the same time. And, you know, like there are very little examples where reduction is taking place and oxidation isn't. If one is, very likely the other is as well. Okay? So a redox reaction is where reduction and oxidation are taking place. Oxidation is loss of electrons. Reduction is gain of electrons. Cute little sign over here. Let's move on. Same equation as earlier. Now, one thing you'll realize about, so we talk a lot about electrons, right? We'll talk now also about oxygen. We'll try to understand oxidation and reduction in terms of oxygen. And we'll think of it in terms of hydrogen. I don't have space, so hydrogen, right? Okay, so what's really happening? Let's talk about the same way in terms of oxygen, right? What's going to happen to oxygen every time it reacts? If it's a pure element, if it's just O2, it'll always react to form 2O2 minus, right? So it always gains 2 electrons. Here's my half equation for oxygen. So oxygen, no matter what, will always end up gaining 2 electrons, right? If that's the case, I can, so over in this particular case, it's kind of hard for me to realize what's exactly happening to electrons, right? But I can clearly see magnesium is gaining oxygen to form magnesium oxide. So another definition I could come up with, just making my life easier, is instead of thinking in terms of electrons, I can think of in terms of oxygen. Because oxygen will always gain electrons. Anything reacting with oxygen will always lose electrons. So what is exactly loss of electrons? If something is undergoing a loss of electrons, so that's essentially oxidation. So anytime anything that reacts with oxygen will end up losing electrons. So anytime magnesium reacts with oxygen, it will lose its electrons to form a compound, right? So every time magnesium gains oxygen, so to speak, that's oxidation. Let's say if you had sodium instead, some other metal, a group 1 metal, right? Let's try writing the equation down for it. Sodium reacts with O2 to form Na2O. To balance it out, it's 4 and 2 over here. Sodium reacting with oxygen currently it has a plus charge over here and a 0 charge. What happened to its electrons? By reacting with oxygen, it always formed a plus charge. Or you could go the other way, because it's a group 1 and it'll always form a positive ion. It's good at reducing, is another conclusion you can make. But for now, let's focus on oxygen. Every time something gains oxygen, see it as a gain of oxygen. Magnesium is all alone, elopes with oxygen and has essentially gained oxygen, so it's oxidation. Why? Because gain of oxygen is considered, is effectively losing electrons, so it's called oxidation. So every time anything's either losing electrons or gaining oxygen, you can quickly go, well, that's oxidation. Gotta be oxidation, right? Let's move on. Similarly, a loss of hydrogen is considered oxidation as well. If something has hydrogen already with it and it loses it, in this case, it's considered to be oxidation. Why, you may ask? Great question. So sulfur over here has a charge of 2 minus, and now it has a charge of 0. Why does it have a charge of 2 minus? Because it has hydrogens, which has given it 2 of its electrons, because hydrogen always forms a plus ion, right? Like a positive ion. So sulfur has to be 2 minus because of 2 hydrogens, 2 positives here. So once it reacts and loses the hydrogens, essentially it's losing the electrons as well. Losing its electrons should immediately trigger what in your head? Well, that's called oxidation, right? It's oxidizing, because loss of hydrogen can also be seen as oxidation, right? So you have up to 3 definitions now for redox. Now if someone asks define oxidation, you don't say anything about anything, you don't know anything, just talk about electrons. But these are tips to quickly identify oxidation. Similarly, you'll have quick ways of identifying reduction as well. Okay? I hope this helps. We'll continue in the next lecture.